I want to introduce reinforcement learning. So let's have a look at it. So reinforcement learning is a little bit different to the learning that we have seen so far. It is considered goal-directed learning and decision-making. So it is distinguished from other approaches by an emphasis on learning from direct interaction with the environment and from not relying on supervision or complete models of the environment. Excuse me. So the idea is it's not supervised learning like we have seen in neural networks. So where does this thing come from? Well, it's kind of motivated by observing how people learn. So we interact with our environment, and as we do so, we get constant feedback. And some of the feedback we may choose to ignore, rightfully so, and some feedback we might decide to integrate into our worldview and our behavior, the way we behave. So here's an example. An infant plays, looks around. Sometimes obviously it has a very explicit teacher, but sometimes it doesn't, especially when it comes to crawling and to walking. Yes, there's some help, but in the end of the day, the child needs to, or the infant needs to learn how to walk on its own. When we learn to drive a car, we get feedback from the car, the way it behaves. Maybe it swerves, it goes back and forth. And sometimes, yes, from fellow drivers. Some of the encouragement is very positive, some of it is not so positive. When we hold a conversation, we're certainly aware about how our environment responds to us, the way we interact with them, perhaps by tone, the kind of arguments we make, how well thought out they are. So we get feedback about that. So reinforcement learning then is learning what to do so as to maximize a numerical reward signal. So it's computer science, so we're going to abstract things quite a bit. We formalize things quite a bit. The learner is not being told what action to take. Instead, they discover which actions yield the most reward by trying them. The idea here is, or a key aspect of reinforcement learning is that the idea of an immediate reward and then after a certain amount of time, a much larger reward. So think about college, right? Maybe not the most fun to do all those homeworks, prepare for exams, take them, and some of the programming assignments you have to do, but you do it, right? Because there's this huge reward at the end, that diploma, right? And a really nice cushy job. So that's kind of like a key aspect of reinforcement learning. There are these immediate rewards. Sometimes they're positive, a lot of times they're small, sometimes they're negative. Again, typically they're small, and then at the end there might be a huge reward. So we have seen now that there's this idea of immediate and later and large reward, and we also know that we sort of like explore our world, right? Which actions yield the most reward? So how do we know that, right? So reinforcement learning is also kind of computationally expensive in the sense that we run many training episodes. Well, not training episodes, but let's call them exploration episodes. And so as part of that, we eventually will gain some knowledge about the world. We will sort of like develop a model of the world. This action in the past was very helpful. It gave me a positive reward, led me in the right direction. This action, maybe not so much. But there are many actions to take in many different situations. So sometimes we want to sort of like go with a known reward, and sometimes we might want to say, geez, I never tried that other action. I wonder what's going to happen. So it's this idea of exploration versus exploitation. So again, initially you probably want to explore quite a bit, and once sort of like you get a better view of the world, you sort of like tend to exploit things a little bit more. And again, the view of the world doesn't suddenly pop up for all the different states you can be in, but sort of like, it's sort of like shining a light in the darkness. You sort of like explore the world more and more, and so some things, I'm pretty comfortable with this aspect of the world, not so much with the other aspect. So it's not suddenly pop up out of the dark. You sort of like really have to explore your world, and you explore more and more of your world. So that's the idea between exploration and exploitation. Exploiting what you already know and exploring new things. Let's move on. We already said that. So in that context, the reinforcement learning is set to explicitly consider the whole problem. So we don't just sort of like look at the immediate. It's not a greedy search like greedy best first search, but we know, we're aware that there are bigger rewards at the end. So yes, we're sort of like perhaps willing to take some pain to get the gain at the end. So this is different to some approaches where we sort of like first maybe solve subproblems and then we sort of put them together maybe in some sort of constraint satisfaction way. And so that's kind of like a key idea of reinforcement learning. We do look at the whole. So in chess, for example, there might be an immediate reward to a move. So perhaps a positive reward, you take your opponent's piece, and maybe a negative reward where you sort of like lose a piece, you sacrifice something, but then again, you sort of like a good chess player will look at the overall situation, the overall strength of the situation. So I want to improve the strength of their pieces, and so like obviously do the opposite to their opponent. So let's get a little bit more technical. And so there are a couple of things we're going to be looking at. The reward function, we already talked about that a little bit, a value function, a policy, and optionally a model of the environment. So as it turns out, we're going to be looking at three approaches here. We're going to look at value iteration, at policy iteration, and what is called Q-learning. Well, today we're only going to look at value iteration, and the next time we're going to look at policy iteration, and we provide some additional formal background of reinforcement learning, and then next time after that we're going to look at Q-learning. So let's have a look at the world that we're going to be staying in here for a while. So this is a very simple world. Our agent lives in a grid. There's the edge of the world. We want to avoid it because we fall off and we know bad things are going to happen. There are walls. In this particular example, there's a start state over here. And so we want to know, where should I go, right? So there is a big reward at the end. So in this particular example, there's a positive reward of +1 over here and a negative reward of -1 over here, trickily put right next to each other. So we kind of want to end up over here, and we want to avoid ending up over here. Okay, so that's the idea. All right, so let's have a look at the small rewards at each step. So right now we've left that out. We have the big rewards, positive and negative at the end. So here is an example. Suppose each step that we take has a negative reward of -0.04. So we go over here, -0.04, over here, -0.04, over here, -0.04, over here, -0.04. So what do we have? -3.6 +1. So still good reward at the end. So the question now is eventually what to do. We're over here. Am I going to go this way? Am I going to go that way? So notice if I go this way, I can go over here, over here, over here. And maybe I misstep and end up over here. Probably want to avoid that, right? So let's sort of like explore some of these things. Again, today we're going to look at value or utility functions, and then we're going to look at policy. So the reward only focuses on a particular step that we're going to take. From here to here, negative reward. From here to here, positive reward. But what we really want to know is, you know, in order to determine a policy, should I go this way or that way, I kind of need to know a little bit more information, and that's where the value function comes in. So some people call it a value function, some people call it utility function, and some people, like me, will use both of them at the same time. So just be aware of that. So the value then of a state represents kind of like the amount of reward an agent can expect to accumulate from that state. All right, what does that mean? So ideally, if we over here, that should be, this state should have a pretty high value because it's right next to the positive reward, right? This one should have a lower value because it's right next to the negative reward, although not too low because if we go this way, then there's a high reward, right? This one over here, man, that's a bummer. So like, you know, if we play our cards incorrectly, we're going to have this high negative reward. So we need to capture the value of each state based on where we can end up. So let's sort of like ignore this one here for a moment. So this one should be high value because I'm right next to this positive terminal reward, right? And this one should be pretty good too because I'm right next to this one. And this one should be pretty good too because I'm right next to this one, right? So that's kind of like the idea. So this should be reflected in the value of the states, how close we are to this positive one, and of course, how close to also the negative one. So that's what the value function will capture. Um, let's have a look at a value function. So, ta-da, here's a value function. How to calculate that thing, we will see later on. So look, this one has a high value because it's right close to it. This one has still a pretty good value because we can go this way, right? But not so good because, well, we can also end up this way if we're not careful. Same thing over here, kind of low. So because if we make a wrong move, we end up with a negative reward. So going back to this one over here and looking ahead a little bit, notice that if I'm over here and if I were to go this way, I would sort of like realize that, oh, wait a minute, this is kind of sweet. If I go this way, hey, that's not too bad. But comparing these two, we probably want to go this way, right? Because this one leads to a higher reward. So now you can sort of like get a sense of how we eventually develop policy. So what is a policy? A policy is a mapping from states to actions. So the idea is it's almost like a compass. I'm over here. Which way should I go? And the policy will tell you, you should go this way. All right. So that's kind of like the big idea. So policy depends on the rewards, but primarily on the value and the utility function that we learned. So here is the utility function that we eventually learn how to create, and here's the policy that was developed on this thing. So if we are over here, then yes, we should go up north. If we're over here, we should go north. If we're over here, don't go down, go to the right. If we're over here, don't go to the right, go up, right? If we're over here, don't go up, go to the left. If we're over here, go to the left. So that's kind of tricky. Well, why wouldn't we go over here? This one has a higher value. Aha! We will see in a moment why that is so. And to give you a slight spoiler alert, slight spoiler here, it depends. What we're going to be doing is we are eventually going to move to a probabilistic transition function. And so things don't always work out the way we would like them to work out. All right, we will have that next. I will see you then. Bye.